We shall see GATE 2020 set 1 question number 35. Okay, so this question goes like, consider two exponentially distributed random variables. So exponential distribution is the first thing which we can derive from this particular question. Exponential distribution, random variables x and y both having a mean of 0.5. So mean of x is equal to mean of y is equal to 0.5 is what they have given, and z is equal to x plus y. That is one important data. Okay, and r be the correlation coefficient between x and y. So r is the correlation coefficient. R is correlation coefficient. Okay, and variance of z is equal to 0. Okay, variance of z is equal to 0. Then r is equal to what is the question they have asked. So now in important thing which we need to know over here is, in exponential distribution, mean of a variable. Okay, let's assume that we have like mean of x. So this is the data. Okay, so this is gonna be solution. So okay, so this is gonna be the solution. So mean is actually equal to standard deviation, okay, of that variable, so which is sigma x, right? Mean of x is going to be sigma x in exponential distribution alone. Okay, mean is going to be the standard deviation, which is also equal to root of variance. Okay, so first thing to have it in mind is this. Next thing to have in mind is that we need to find the correlation coefficient. So we use this particular variable, or sometimes we use correlation coefficient as rho. Okay, of correlation coefficient of x and y, right? So x and y. So for that we need to have covariance of x comma y divided by sigma x dot sigma y. So this sigma x and sigma y is actually the standard deviation, which is also they have set it as 0.5. So these two data are with us. Now it is our duty to find this covariance x comma y. Then we can go ahead with the final required answer. So now let us move on. Sigma x and sigma y is already there with us, right? So now next is we have a formula in which it is variance of ax plus by, okay, is equal to a square variance of x, okay, plus b square variance of y plus 2ab covariance of x comma y. Okay, so now since they have given z equal to x plus y, so coefficient of x is equal to 1 and coefficient of y is equal to 1. So now let us try to rewrite this. So variance of z is equal to variance of x plus y. Since in the question they have given z is equal to x plus y is equal to, consider this to be as ax plus by. So a is equal to 1, b is equal to 1. Just apply that particular formula. A square is 1 square, 1 square is same 1, so I'll write it as variance of x. So b square is again 1, which is variance of y, plus 2, ab is 1 1, covariance of x comma y is what they have given, right? So now next step is to like covariance of z, already they have given in the question. Variance of z is what? It is 0. So variance of z already they have given it as 0. So now what we could do is solve this for covariance of x comma y. Since this is 0, so this whole term is gonna be 0. Now what we are gonna do is covariance of x comma y is equal to minus variance of x minus variance of y divided by 2. So what is variance of x? Variance means it's root of SD, right? So variance, root variance. So if you do this, you will take square, right? So you'll take square and you'll take square for 0.5 also. That will be the variance. So variance is gonna be, since it's square, it's gonna be minus 0.25 minus 0.25 divided by 2. Again it's gonna be minus 0.25. So which is covariance of x. So now let us put this covariance of xy, which is 0.25, okay, in this particular formula. So you will get the final answer, which is required one. So correlation coefficient of R for x comma y, or rho of x comma y, is equal to covariance of x comma y divided by sigma x dot sigma y. So covariance of x comma y is, as we have seen earlier, it's 0.25 divided by sigma x is 0.5, since that is the mean itself, and again sigma y is also 0.5, that is the mean itself. So solving it, you will get -1, so which is the required answer. So -1 is the final answer. So let us write it over here. So final answer is -1, which is the required one. Thank you.